In this lesson, we're going to get an introduction to the three reciprocal trig functions and see what their graphs look like. So you're already familiar with the graphs of y equals sine theta, y equals cosine theta, and y equals tangent theta. And each of these trig functions has a reciprocal function. If we take the reciprocal of sine, we define that as the cosecant function. So I'll write this out in full words and then the abbreviation. So 1 over sine theta is the same as cosecant theta. And so we write that as an abbreviated form, looks like this. CSC is the abbreviation for cosecant. If we look at the reciprocal of cosine, 1 over cosine theta is defined as secant theta, and the abbreviation 1 over cosine theta is SEC theta. And then tangent has a reciprocal just called cotangent. So 1 over the tangent function is called the cotangent function. And so 1 over tan theta is COT theta. So those are our three trig functions, reciprocal trig functions, cosecant, secant, and cotangent. And so now what we're going to do is we're going to look at the graphs of those. And so the easiest way to do these, since we know that cosecant is the reciprocal of a sine graph, the easiest way to graph cosecant is to graph its reciprocal function first. And so we'll say for this one, we're going to graph y equals cosecant x. And so we know that cosecant is the reciprocal of sine. So I'm just going to start with a normal sine graph. Okay, so this is what I'm graphing as y equals sine of x. Which we've seen many times before. This is pi over 2, pi, 3 pi over 2, 2 pi, and so on. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, now that graph's important because since we know cosecant is 1 over sine, then whenever sine is 0, cosecant is going to be undefined. So anytime this sine graph hits the x-axis, that means its y value is 0, and so our cosecant graph is going to be undefined. So that's going to create asymptotes every time sine crosses the x-axis. That's going to create an asymptote for cosecant. So I'm just going to go ahead and put vertical asymptotes every time sine hits the x-axis. Okay, and now in red, I'm going to start graphing the cosecant graph. So when sine is 1, the reciprocal of 1 is 1. So we know our cosecant graph is going to whenever sine is 1, cosecant is also going to be 1. Whenever sine is -1, cosecant is going to be the reciprocal of -1, which is also -1. So it's going to go through those points. And then it's as sine gets closer to 0, cosecant is going to grow toward infinity. So this is going to go up toward infinity as sine gets closer and closer to 0. And so since it's a reciprocal, when the sine values get small, moving along here, when the y values get small, the y values for cosecant get big. So again, as we move along here, sine is getting smaller and smaller, meaning a smaller y value. So that means the cosecant graph gets larger and larger. And we see the same thing here, but with negatives. So as sine gets closer to the x-axis, cosecant goes to infinity. And so if we continue doing that on each interval, we see that this pattern just keeps repeating itself. So small sine values make large cosecant values, and large sine values make small cosecant values. And so that red graph is what our graph of cosecant looks like. And so every time you graph a cosecant graph, I suggest that you just start with the sine graph, and then the highs and lows become points on the cosecant graph. And if you draw the asymptotes whenever the sine graph hits 0, then that'll help you guide your curves towards the asymptotes. Okay, so that's what the graph of cosecant looks like. Now I would like you to try, for the next example, try doing something really similar to that for secant, which is the reciprocal of cosine. So for example, 2, graph y equals secant x. And so pause your video, see if you can first graph a cosine graph and then graph its reciprocal, and then press play when you're ready to check your solution. So a cosine graph starts high at 0, and so I'll just graph a normal cosine graph first. Okay, and then just like we did previously, whenever the cosine graph hits 0, since secant is the reciprocal of cosine, if the denominator is 0, then secant's going to be undefined. So that's going to create vertical asymptotes whenever cosine is 0. Okay, and then now we're ready to graph the secant graph. When cosine is 1, secant would also be 1. And so at all of these high points, cosine and secant are going to be 1. And then from those high points, it's going to approach the asymptotes. And then the same thing happens when cosine is -1. It's going to start down here. If cosine is -1, secant is also -1. And so they share those points in common. And so that red graph is the graph of secant. Okay, and then our last graph today is going to be the graph of cotangent. And cotangent, remember, is the reciprocal of tangent. So you might remember a while back we learned how to graph tangent. And tangent, remember, is the reciprocal of tangent is the quotient of sine over cosine, so that means cotangent would be cosine over sine. And so we can graph a tangent graph first. So tangent, we said, was undefined whenever cosine is 0, and that's at pi over 2, negative pi over 2, and 3 pi over 2, and 5 pi over 2, and so on. Okay, so a tangent graph, when we graphed that earlier in the year, looked like this. And since cotangent is the reciprocal of this, whenever the tangent graph hits 0, that's going to create the asymptotes for our cotangent graph. So every time the tangent graph crosses the x-axis, cotangent is going to be undefined. And since cotangent can also be written as cosine over sine, whenever cosine is 0, that's going to make cotangent equal to 0. And so cosine equals 0 at pi over 2, 3 pi over 2, 5 pi over 2, and so on. So what used to be our asymptotes on the tangent graph, so that's the blue dotted lines, become zeros of the cotangent graph. And so if let's look at what happens when I plug in a number that's getting closer and closer to pi. So this quotient, when I get closer and closer to pi, cosine is going to be approaching -1, sine is going to be approaching 0. So we have this quotient where the denominator is getting really small, but it's positive, because if you think about on the unit circle, when you approach pi, if you have angles that are getting closer and closer to pi, the sine value is positive but getting very small. The cosine value is negative, getting closer to -1. So if we have a quotient of a negative number divided by an extremely small positive number, that's going to go to -infinity. And so we said as we get close to pi, it goes to -infinity. As we get close to 0, we're looking at a quotient where the cosine value is 1 and the y value is getting close to 0, and they're both positive. So that would go toward positive infinity as we get close to 0. And so we see that this looks very much like a tangent graph, but just flipped in the other direction. And the zeros of the tangent graph become the asymptotes for the cotangent graph, and the asymptotes for the tangent graph become the zeros for the cotangent graph. So they just kind of have opposite roles in this case. So our red graph now is our cotangent graph. And that completes today's lesson on graphing the 3 reciprocal functions. Have a great day.